change the world. Making fire is an obvious one. The wheel, of course. More recently, the steam engine, the light bulb, the automobile. But if you want to talk about really recent history, you probably couldn't find a better example than the computer. As a tool for communication, for creativity, for engineering, and for so many other uses it would be hard to list them all, the computer revolution transformed our world profoundly. Which is why researchers find it so exciting that there may be another computer revolution in the future. Many scientists think we're in for another quantum leap in computing, and that could come appropriately from a quantum computer. Dr. Daniel James thinks quantum computing is a technology that could change the world. He's a professor in the Department of Physics at the University of Toronto and holds the Canada Research Chair in Atomic and Optical Physics. So, Dr. James, how will quantum computers be different from the computers we already have?
Well, it's somewhat fundamental that a computer that you have today is made up of lots of devices to store information. We break this information down into yes-no answers, so we're called bits. So it's a 0 or a 1 is a yes or a no. And each of these bits is stored in a piece of electronic circuitry made of transistors and things like that. Each of these storage elements is always going to be in 0 or 1, a yes or a no. A quantum computer is made up of things which can be in yes and no simultaneously. It's kind of a spooky sort of philosophical transition. How can something be two things at once?
Right. But how does that make it different in the way it operates?
For example, if you want to store information in a computer, you've got just so many options that you could have. But a quantum computer, you could store all possible options simultaneously. So you get quite literally an exponentially bigger storage capacity very quickly. For example, I just did a back-of-the-envelope calculation. If you wanted to read Marcel Proust, for example, the 6-volume novel Remembrance of Things Past, it's about 4,000 pages long. And it's about 30 megabytes of information there if you download it from the net. Now, with a quantum computer, that's 20 or 30 million bits of information that you'd need to store it with. And that's a reasonable-sized computer. If you wanted to have a quantum computer, you just need 25 or so of these two-level systems to store all that information. Because, for example, if you've got one of them, it can be either up or down. Two options. If you've got two of them, the first one can be up or down, the second one can be up and down. That makes four possible configurations. For three of them, it's going to be each of them can be up or down at the same time. That's 8 possible configurations, and go on. Each time you multiply it by 2, so it gets bigger and bigger very, very quickly. Okay, so other than ability to store information, what can quantum computers do that computers today could not? Well, that's just the start of it, this enormous memory that they have, this very big memory. If you then want to do something with this information, like search through it or change something, or when you're a scientist you want to do calculations on it all the time, when you do one operation on one of these qubits, one of these components of a quantum computer, one of these 25 qubits which is storing all the information in Marcel Proust, then you're going to change all of the bits of information simultaneously. All of that information gets transformed by just one operation. This is called a massive quantum parallelism, it is called. You can do something very efficiently. You can do this information processing very, very, very easily.
Okay, so I can understand how it would have greater capacity, might be faster, deal with information instantly, all of that. But what about the future, about changing the world here, the things we talk about that computers could do, like artificial intelligence and all that?
The vast amount of computing power that this would untap and make available to everybody, it could change our lives dramatically. For example, when you are driving to work, you've got a lot of decisions to make. What road to go, what route to take. There may be roadworks, there may be traffic jams. Oncoming bus, can you make the left turn before it gets to you? Things like that. Decisions all the time. These are boring decisions I wouldn't like to think about, but obviously if I don't think about them, I'm either going to arrive at work 10 hours late or get killed in worst case scenario. Maybe we could have, with computing power, we could have all of the traffic system in a big city like Toronto being controlled by computers, so that all these little decisions that need to get made in order to get everybody to work and home again in the evening could be automated. I mean, the amount of computation that would require is enormous compared with what's available today. But with this enormous growth of computing power that quantum computers could unleash, that might be feasible. We might have, without any loss of the flexibility that our own decision making allows us. We can say we want to go from here to here, and they'll tell us